the thing that I've mentioned up to now are just related to the physical parameters of a temperature gauge, or actually I just introduced the appearance for you. Now I want to tell you how this item can measure the amount of temperature. So let me just write the element one. The first element that I want to tell you is rated for bimetal one. It means that you expect to find two sensors, same as the thing that I'm drawing here for you. The first one with red color, the second one which is the blue one. Okay. These two sensors are metals, and actually both of them have been considered with the shape of helical in the stem. So now you can understand what we have in this stem. That's for sure. It's not a type of liquid such as, for example, mercury or oil or even alcohol or things like that. In an industrial case, we have to use bimetal sensors for measuring the temperature in our stem. So these two metals, which have been considered as the helical one, something just like it, can be found inside. So can you see this part? It would be called as fixed point. This is fixed point. I mean, in just one part, these two metals have been just welded to each other or have been connected to each other, and fixed point actually is here. Actually, at the tip of the stem, there is a place you can find the fixed point. After that, the next part, or the next part of these two metals are totally free here, and both are connected to spring, and finally you have a pointer which can be, which can move actually on the dial. So what's going on here? Listen to me. We have a formula. It's L2, L1, 1 plus A delta T. So L1 is the first length of the device in a normal condition or in ambient temperature. Sometimes actually it is considered in a temperature of 0 degrees centigrade as well. L2 is the length of this device after changing the temperature or reaching to the temperature that we want. A is a factor, is a permanent factor for these things, and delta T is the changing of the temperature. These two metals must be considered with a different permanent factor, and these two sensors, or these two metals should have different A factor with each other. For example, A1 here and A2. Do not forget, these two factors must not be similar to each other, or even they must not be considered as close to each other too. As I mentioned, that these two items should be really different from each other. There must be a really difference between these two things. For example, we can just consider iron and platinum for these types of things, but actually again it depends on the manufacturer and its standard. So what's going on here? Just imagine I just put this fixed point in the contact of fluid. So it means that the time that the temperature increases, we expect that the length of this helical shape is going to be increased too. So that's for sure. It cannot be expanded, horizontally. On the other hand, it must be expanded in the vertical line or vertical arrow. So what's going on here? Just because of the helical shape of this one, by the time that we reach to the free part of the sensor, we can find actually this length is going to be transferred to the spring, and just because of increasing the length of this device, this spring is going to be actually stretched, and after that the pointer is going to move on the dial. Now you can just find out why these types of limitation have been just discussed or have been narrated for you, because as you can understand here, this formula is just linear in a just constraint temperature. We cannot actually expect that this item is totally linear for all the temperature.